wrote the initial version of tbDEX on top of Web5.js primitives. So we have this really great JavaScript library that has a lot of things in it related to Web5. So this includes DWNs, DIDs, cryptography, all things that you need to do to work with the Web5 ecosystem and not have to really think about what is an ED25519 private key and what can that do for me. It's kind of all abstracted away from you, and it kind of helps you work with the system a little bit easier. So for the tbDEX that we launched in Africa here, we actually made a corresponding JavaScript library for that. So this leverages our Web5.js library and uses it to build upon the primitives of like DIDs and our cryptography to create tbDEX messages. And all of these are kind of overviewed on our developer website. I'm not going to go into too much detail here because it's, for the purposes of this conversation, it's not all that interesting. But as part of, so we worked with Yellowcard first. We built a JavaScript library. We're also working with other banking partners, such as Yellowcard. I can't really divulge into who they are or what they are, but we've been kind of naming them after birds. So if you see like Project Eagle, Project Penguin, Project Black Eagle, there's like a zillion of these things. So you might see some bird names. But all of these correspond to us working with the new partner and trying to get them up to speed. And one of these partners, they didn't use JavaScript, they used Kotlin. So how did we stand up tbDEX and allow them to interact with our protocol? Well, we had to create an entirely new SDK. We had to create a Web5 in Kotlin, and we had to create a tbDEX in Kotlin. So this is all work that was done within the last 3-4 months, I want to say, to bring tbDEX protocol into Kotlin. So now, in addition to the JavaScript SDK, we have a Kotlin SDK. The keynotes there, I guess, are our Web5 Kotlin SDK is far less robust and feature-rich as our JavaScript version. So for example, we are not using DWNs whatsoever in our Kotlin version of Web5 KT here. You won't find anything related to DWNs because we haven't implemented it. It may come in the future if and when tbDEX requires DWNs to work, but right now it doesn't, so we haven't implemented it. So that brings us to the third SDK we're writing, and we are writing it in Rust. But Rust wasn't really the initial reason why we started writing this third one. The requirements are we need tbDEX to run on Swift. So the Apple programming language Swift, so that we can run on the iOS platform. And this is again in our goals towards working with banking partners directly. So we have a requirement on iOS. And Mo and Frank, we kind of took a look at the Swift ecosystem prior to this and found out that, hey, there's not a whole, like all the crypto stuff that we're using underneath the covers, like SecP256, ED25519, all of the curves that we're using to sign and verify data, that stuff doesn't really exist in Swift as readily available and as quality as it is in other languages that we've been using so far. So we looked around and we said, hey, what else could we write a Swift SDK in and export it to Swift? And that is the entire reason why Rust was even investigated in the first place. So we went down this road of how could we use Rust in order to provide us a tbDEX SDK that can run on iOS. So that is what everything has been in preparation to, kind of sets the stage of why we're even doing what we're doing here. And this brings me now to where we are today. So here, we've started writing this in Rust. And we're gonna go into a little overview of what we have so far in terms of our SDK and where we are going here. So right now, we essentially have two different repositories kind of mimicking what we have in the JavaScript world and the Kotlin world. So we have a Web5 RS, which is our Web5 specific Rust code. And then we have a tbDEX RS, which will house our tbDEX specific Rust code. Most of the work so far has been done in Web5. So what do we have today? Well, we have a bunch of crates that correspond to what we have in the Kotlin version today. So we have things like crypto. So we have different signing keys, or signing private keys and public keys that can be generated in different ways. This is all written in Rust right now. And it is written with the express goal of getting to Swift as quickly as possible. So we have taken things off the shelf. So as you see, we're using third-party libraries to define things like JWKs. But all of this code in here is pure Swift. We are trying not to make any compromises whatsoever, and we are writing our Rust code in a way that you could take it off the shelf and run it in your Rust application. So we have things like keys, we have crypto, we have, let's go back here, we have key managers, so we have implementations to store your private keys in memory. We also have different ways of creating DIDs, very similar to what we have in the Web5 JavaScript and Kotlin world. And we have 3 methods right now, so didKey, didWeb, and didJWK. And again, we are writing this for the express goal of getting to Swift as quickly as possible. So we have taken off-the-shelf, already implemented implementations of didJWK. We're just calling out to them to generate our DIDs. We are not doing anything special in-house. Decentralized identifiers are a standard. Somebody else already implemented the standard. We're gonna just use it. We're not gonna reinvent the wheel here. So that's a little bit of an overview on where we are in the Web5 world. On the tbDEX side of things, this is very green. We barely have anything here because a lot of this relies on how Web5, like how we create DIDs and things. So if we go into here and look at, let's take a message, for example. We have what is a tbDEX message written out in Rust right now, but you can't really do anything with it yet, because in order to do anything interesting with a tbDEX message, you really need to verify that it came from a reputable source, which you need DIDs in order to do. So kind of a very, very high level overview of where we are on the Rust side in terms of progress so far. Now, note, I've only been talking about Rust so far as I've been going through these libraries that we're making in Rust. And I said not even 5 minutes ago that our express goal of writing this Rust SDK is to get us onto the Swift ecosystem and on the iOS platform specifically. So how are we going to do that? And that is currently what we are working on and what is proving to be very difficult in terms of memory management. Rust is a very safe language when it comes to memory, But as soon as you cross the language boundaries, things get a little weird because the same memory management rules in Rust do not apply on the iOS side, for example. So how are we approaching that? We are going to be using this library called Unify. And what Unify does is it generates bindings in target languages to call into your Rust code. And by default, they support Swift, Kotlin, Ruby, and Python as their native languages. They also have third-party support here for Kotlin multi-platform, Go, C#, Dart, and there's constantly being new languages added here as well. So the thought process here is we write our core logic in Rust one time, and then we use Unify to export bindings into the Rust code from various other target languages. And right now we are only focused on Swift as our first language here. So what does that look like? Right now, none of this is in the mainline branch right now. So this is all on, so if we go back here, let's go to the Web5 RS. So if we go to branches, landing PRs has been a slow, steady process here. So all of what you are going to see is in this PR progress branch on the Web5 repository here. And at first glance, this kind of looks very similar to the current setup that we have today. But specifically, on this branch, there are bindings that we are generating for the various parts of Web5 Rust, and we're exposing to target languages. So a really good example here is our DIDs crate in Rust. How are we exposing DIDs functionality to iOS, to the Swift programming language? Like I said, we're using Unify as our library to generate our bindings. So you'll see that in the cargo file for this particular crate. And what this is doing is in here, we define all functionality that we want to expose to third-party languages via this, it's known as a UDL file. And this is all documented. Unify has a really great user guide in terms of how does this thing work. It's a very, very complex piece of software. Mozilla is authoring it, and they are using it to bring Firefox to multiple platforms right now. So they have their own goals with the library. They align pretty well with us, but along with it, they have really great documentation in terms of like what kinds of things can you expose via a UDL file. So we can expose all these different types to our target languages, and we can generate code for these target languages as long as we speak this UDL language. So if we go back over here and look at this UDL file is explaining to Unify, this is what I want to expose to my foreign languages here. So the syntax is a little odd, I won't lie here, as with all intermediary languages that explain or that define cross-language boundaries here. But you can start to see some of, if you've looked at the SDKs for Web5 and tbDEX, you're starting to see some things that probably look a little bit familiar to you. So like we define, hey, there's a key manager, there's different key types. DIDs can throw errors. And I can create a JWK DID using a particular key type. And it has an interface where I can construct a DID JWK with a key manager and some options here, which relate to a key type. So this is how we define how this looks like to external languages. And now how do we consume them in target languages? Well, because we've defined it in line here as this is the interface that we are exposing to our target languages, this code can automatically get generated into Swift code. And this is all done at compile time of the Rust code. So if we cannot fulfill this contract that didJWK, you can create a didJWK with a key manager and some options. If this is not possible in code, it is a Rust compilation error. You literally cannot build the library at all until you fulfill this contract in here. And what this does is it allows for very, very powerful code generation. So I didn't have to write anything to write this code. All I do is I literally say, didJWK, I'm gonna create a key manager. I'm gonna create one with you with this particular key manager and this particular algorithm. And I didn't have to write a line of custom Swift code. I just had to execute the Rust code via Swift. So this is where we're going with the Rust SDK and kind of why we've made some of the decisions that we've made here. I know that there's a lot of questions regarding our Rust. So that's really all I had in terms of this is what's going on. We are currently in the process of getting this working in a friendly way for some of the more edge casier things that we want to be able to allow people to do with this library. So for example, what we want to be able to do is allow Swift to write their own key manager that stores keys in the keychain or the secure enclave. I'm having a very difficult time getting that working right now due to just Rust is very unfamiliar and there's a lot of rules around memory management that I just need to learn and I'm getting better at. So that's kind of the state of where things are, where we're going. Now, how can anyone help? Because there's a lot of work here. How can anyone help? There's plenty of ways that anyone can help further progress this project along. We need Rust developers. We need people to be able to write Rust code and be able to implement these crates in pure Rust. That is the first battle that we need to get over. I know there's been a lot of pushback on not rolling our own did methods within Rust here. If we want to, yes, we can absolutely roll our own did creation and resolution, and we can be as innovative as we want to in the decentralized identifier space. But I needed something to prove out the rest of this flow because again, Rust is not the end goal. Swift is right now. Long term, yes, we want to maintain and build this Rust library. So a lot of work needs to be done here in the Rust side. Not only here, but the bindings part. This is actively being worked on. If you know Rust memory management and how that works, would love to hear from you. Would love your insight on some of this stuff because this is very complex stuff. More immediate term things that can be done, tbDEX and defining what messages are and how a message has data that's comprised of RFQs. All of this needs to be implemented in Rust, and then we need to export it into target languages. So we need Rust developers here as well, implementing all of the things that we want to do for the tbDEX protocol. So there is no shortage of work to be done here, and there are plenty of ways to get started. I've created issues for basically everything that we need to be doing in the tbDEX library right now. And these are all pure Rust implementations. And then on the Web 5 side, we've kind of gotten the crypto, DIDs, and credentials part as far along as we need them to be for the time being. So most of the work in Web 5 is related to foreign function interface or implementing our own decentralized identifier implementations. So yeah, I know that was a lot. That's really all I had to talk about today. I'm going to stop sharing my screen and open it up for questions. I know this was a lot of stuff that I just spewed out. Would be more than happy to answer any questions. If there's tactical, like in the weeds code questions, if there's more strategy questions, more than happy to answer any of those.
Yeah, I have a quick question, Adam. Yeah, good job on all this. This is really cool. Just wanted to see, like, when you import, like, I guess if you share again and you kind of go back to the Swift code and you actually import the bindings, I guess, are you just importing like locally, or is this actually like automatically spitting it out to like a repository that you can import?
Great question. Let me find how in the world to share a screen again.
Oh no.
There we go. Okay, cool. So if we go back over to here, so this is Swift code.
Yep.
I'm not gonna lie, this is completely hacked and squashed together. But at the very top, we import what obviously these names are going to change in the future here, but we directly import crypto and DIDs here, and we use them within the Swift code. And the way that kind of works right now is I have this very, very gnarly bash script that takes the generated code that Unify provides us, and all it does, this is a very long-winded way of saying create an XC framework, which is pretty de facto in the iOS development space as a universal framework file that I can pull in. It's got debug symbols, it's got release symbols, it's got different platforms, so I can build for iOS, I can build for macOS, I can build for tvOS, I can do everything with Apple platforms in this framework. So there is a step here. We do need to automate this part, but right now it is a simple script that packages it all up together.
And then, so if I understand, like when we do Java, right, we would have to probably make a jar, maybe make a script or something that would make a jar.
Exactly. Yep. So Unify creates all these files. Unify doesn't really care what you do with the files. So it's our job to package them up and provide them on the platform where they're going to be consumed. So yeah, this applies, like obviously this is going to apply to iOS. We're going to be publishing to like the Swift package index with the library that we make out of this. But you could imagine like, hey, we want to make, I don't know, a Python library out of this. Mm-hmm. It's literally one extra word, the word Python, and we have Python symbols and Python bindings. Mm-hmm. All we need to do is package those up and publish them on pip or whatever we want to publish those on.
Awesome. And then just one other question is, I don't know if I heard JavaScript, if it supports JavaScript or WASM.
Yeah.
Maybe it doesn't. But I guess if it doesn't, then I guess we would live in a world where we're going to have Web 5.js, and then we're going to have like this for pretty much everything else, maybe. Is that?
Yeah.
Thoughts on that?
So Mo and Diane have actually been looking into this far more than I have. So if either of you want to speak towards this, feel free to jump in. But Unify is more targeted towards native languages. So think of like your Swifts, your Kotlins, your Rubies, your Pythons. Um, WASM is a first-class supported uh, thing in Rust. I guess I don't really know how to speak to it too much, but WASM is completely different and it uses a different code gen path entirely. If you read through Unify's documentation, they've modeled everything after Rust's WASM support, actually, because it is so nicely integrated into the language. So yeah, Mo, Diane, if you have anything else to say regarding to that.
Yeah, sure. So, I haven't looked like under the hood on like the Rust support for WASM, but I can say as someone who has now, compiled Rust down to WASM, it is pretty like nice to use. Like as a user of that feature, I'm pretty happy with it. So this girl math library here, it's also like a Rust library that Mo and to a lesser extent I have worked on a bit. That is in Rust, and there are now JS bindings in it. It so we use some other libraries in addition to like just the you know Rust compiler. So we use wasm bindgen, which is a way to put annotations in the Rust code itself that tells um, that kind of informs how the bindings should be generated, what those should look like, and then wasm pack, which kind of does some bundling for us. Mo actually has a draft PR up right now that does some of the kind of what's the word for polymorphic JS stuff. Um, and it ended up being, because there are other projects that have kind of trodden this path before. It's not the most clean process, to compile Rust to ESM and common JS bindings, but it definitely is possible. And for consumers of these libraries, hopefully it will look clean from the outside.
So, Adam, if you go to the experiment branch here, so if you look at the crates girl math directory, that's the actual Rust that we've written. So if you go to source, there should just be a lib directory or file. This is the actual pure Rust code that could be pulled in as in another Rust project and used. Now, if you go to the bindings directory and you go into girlmath.js and then source and lib.rs, you'll see the wrapping code that has to be written. So effectively, if you scroll down a bit, you'll see another major to minor, and we can just look at that. If you scroll back up just a little bit. So yeah, we can look at minor to major. So basically, in the pure Rust, it was returning a result of string. Here, we're returning a result of string JS error, which effectively makes it such that when you're actually using this as JavaScript or on the JavaScript side, if an error is thrown or if an error is received on the Rust or WASM side, it will actually bottle it up and throw it as a pure JS error. So there's the actual Rust code and then the wrapping Rust code to make it more JS idiomatic, I suppose. And then similar to what you were mentioning, Adam, about the neckbeardy bash script, we have something really similar. If you open up scripts, there's actually two levels of neckbeardery going on. If you go to build.sh, this is a bash script that is doing, it's effectively taking the WASM and base64 encoding it and cramming it into another file. If you go to bundle.js, it is effectively taking the output of wasm bindgen and basically bundling it into a single file. And then lines 23 and below is effectively changing or making the package a little bit more modern in terms of JS. So Instead of common JS, it's ESM, and it's making it such that it can be consumed or used in the browser or in a node environment. And then if you look at examples real quick, if you go to node ESM and look at node ESM.mjs, that is an example of what it looks like to actually use the WASMified Rust library in JavaScript. And I think it's really, really, I guess, minus the 2 janky scripts, it's really nice, actually. So all of the documentation you saw in the lib.rs for girlmath.js actually automatically gets converted into tsdoc. So if you open this in VS Code or another code editor and hovered over major to minor, you would actually see the full, like the entire JS doc that one would imagine you would see if this was just a JS lib. So that's not going to work right now, Adam, because there is no, like, we haven't published this library yet.
Gotcha. I was just curious.
This is super interesting. I had no idea you could do this in GitHub. So yeah, that's the JS story, Neil. Kendall, you do get TS support right out of the box. So there is a .d.ts that gets, there's a .d.ts that gets automatically generated and added as part of the generated JS. It's just that, like here, we can't look at any of that because all of the auto-generated code is get ignored and not pushed to this repo. So yeah, that's pretty much all we've got on the JS side of the fence so far.
All right.
Yep, that's good stuff. It's always like one extra step for the JS, always, you know. And then, you know, always something to look at when we were messing with this earlier is the size of the binding. You know, if it's like a 20 megabyte file or something to load into a web page, you know, it can be problematic, but we'll cross that bridge when we get there, I guess.
Yeah, so to give you an example, so this girl math JS lib with the base64 encoded WASM ends up being, one second, I have it. It's 34.62 kilobytes.
That's great. That's crazy. Awesome.
Yeah, one of the major benefits of using Rust is an extremely efficient language. They put a lot of that onus on you. You have to write your code in a safe way, and there's a very particular safe way to write your code that Rust prescribes. It's not necessarily difficult by any stretch of the imagination, but it's much less familiar than you might be used to with higher level languages. Cool. Any other questions from anyone? I'm not seeing anything in chat. If not, we don't have to use the full hour by any stretch of the imagination. So I guess with that, we can end it there. Thanks, everybody. Hopefully that helped give an overview of where we are and where things are kind of going here.